person, but the idea here is that when we talk about particle motion, we're talking about motion in a single direction. Now, typically that is left, right, or up, down. So when we talk about something that's moving, and they say like, oh, it starts here, and then it goes left, and then it goes back to the right, left, right, left. Now you can see that when we draw lines like that, it's very like, how do you tell where it's going? So sometimes we'll draw like this. We'll go over here, and then it's here, and then it comes back over here, then it comes back over here, and then it keeps going. Now, what I'm drawing here, and the reason why I'm drawing is using the erasable ink part, is that I'm not going to ask you to physically draw those ones, but that's kind of like what we're referring to. You're moving just left and right, or up and down. Sometimes we'll note that the left and right part is along the x-axis, and as such, we might label this as x of t. And when we're talking about up and down, we talk about moving along the y-axis, or we might notate it as y of t. It's a rate. So our just like we were talking about in regards to related rates, these particles are moving in terms as a function of time. But the nice thing about this is that you're going to actually know what the function of t is. So I'm going to give you the function. All right? I'm going to give you, now, you've done a lot of this, and most all of you should have taken physics at some point. Usually ninth grade, I believe, is where everybody takes physics. So there's going to be a lot of connections to that course into what we're going to do today. So when I talk about the position function, this is the location of the particle at time t. So at any point in time t, where is my particle's position? And we'll note s, we might use s of t, x of t, or y of t. Each notation can be used. They all mean the same thing. X, Y help denote specifically left, right, or up, down, while S of t is generic. So I'll let you copy that down and write it. Basically, here's what I'm saying. When I use specifically x of t or y of t, which I'm not going to use much for my notes today, it usually is a follow-up from something in the problem. So we might say in the problem, a spider is moving along the x-axis, is moving left and right. So if you're moving left and right, we're going to utilize the words left and right, and as such, I'll denote that with x of t as the position. All right. And it'll explicitly say like the position function s of t or the position function x of t. Remember, it's just a variable, all right? It's just a variable. These are the three most common ones to use, so I just want to get them out there and stating those for you. We're only moving left and right and up and down. If you take second year calculus, Calculus BC, Calc 2 as they're sometimes called in colleges, you'll talk about movement where you're moving not just in the one axis direction, but you're moving in both the x-axis and y-axis. domain. For particle motion, we denote the start position as t equals 0. As such, t has to be greater than or equal to 0. So our time starts at 0. There's no such thing when we talk about these problems in terms of negative time. We have a start. There's always a start, and that start is denoted as t of 0. So i.e. x of 0, we call this my initial position. Actually, I wasn't going to use the x and y. So if I use s of 0, it doesn't really matter what letter I use. We call this the initial position. We can also note it as the position at t equals 0. But you'll see some me use initial position. In some notations, like I said, the reason why I use that x of 0, you might have seen in physics, sometimes they'll donate it as like with this little 0 down here. It means the same thing. Typically the x sub zeros in the subscript notation is more common practice in the physics course. Okay. Questions on what I've covered so far? So we have position function, which is a function of time. And we have the idea of this domain and starting position at time equals 0. Rate of change of position. What do you call the rate of change of position? What is the rate of change of position? The rate at which position is changing. What do we call that in physics? Yeah, some should have some physics buffs.
We not remember, mister. We not remember.
You don't remember?
Yeah, because I took physics in my first year.
Okay, so you said we. You're speaking for everybody there. So Norda, I saw something?
Oh, yeah, I don't remember.
Okay. Well, just think about it. What was the most common thing that you talked about in physics? When you talked about motion, there's position, and what would be the first thing that would come to mind?
Mister, that was a long time ago.
Okay, you should. Doesn't matter. It's a long time ago. You guys act like you learn things and then you should just forget it, and you're just trying to not think about the concept here. I'm just saying, and all I'm asking is, what was another vocabulary word that you used? What was something else that you looked at? You looked at many graphs of this. When you think about motion, when you think about movement, what do you think about? And it wasn't that long ago.
Oh my god, I think I know. Is it velocity?
It is velocity. So velocity is what we are going to talk about. And velocity is the rate of change of position. So if S of t is position, then ds dt is velocity. It should also be noted that we can use S prime of t, or we can use V of t. It's a very important relationship here that it says the rate of change, which we also call the derivative, the rate of change of position, or the derivative of position, is velocity. Very, very important place. The derivative. And for all of you those that were trying to say it was so long ago, I'm probably saying like, yeah, I know velocity. The derivative of position, I want to say, actually, I'm going to go with the position function. Is the velocity function. Very important. Now, we call this the instantaneous velocity. All right. So I do want to note that we also call this the instantaneous velocity. It is the exact velocity. In your physics courses, you never really worked with functions, because in order to find the velocity function, you need to know calculus. Now, if position was linear, then you did find the velocity, but I don't believe that in your physics courses that you often worked with them as such. I.e., for example, if I said your position function was 5t plus 5, all right, well, the derivative of 5t plus, or 5t plus 3, I want to use different numbers. The derivative of 5t plus 3 would just be 5. And so the velocity would be 5, for those of you who don't want to make that connection. That has constant velocity. In physics, at least in 9th grade physics, you always worked with constant velocities. All right. That was your main goal in terms of, now you might have seen velocity functions, or you might have worked directly with velocity functions that were linear themselves and then didn't ask questions about the position, but we are going to be able to do those now. So we call this the instantaneous velocity. So the velocity, just to repeat it, the velocity is equal to the derivative of position. Whereas in previous courses, you talked about the average velocity, and the average velocity is the position at B minus the position at A all over B minus A. Now, this is a question that can be asked. I can ask you, what is the average velocity? And you note that as the change in position over the change in time, the delta S over delta T. This is what you found in your previous courses. You approximated. You didn't find the velocity at time equals 5. You never found that, really. You always found the average velocity from time equals 0 to time equals 5. We're going to be, our major focus here is going to be on the velocity function, the derivative. So, if given S of t, you can find V of t by differentiation. So you're going to take some derivatives. Now, the good news in tonight's homework, most all your stuff is going to be in polynomials, so only the power rule. All right. What happens once you find the velocity? So you might have to find velocity, or velocity may be given to you. Okay. I believe in all your homework problems, like they start off, they give you position, they ask you about velocity. So velocity in context. So you're going to be asked, mostly in tomorrow's, to explain in context, what does this mean? So, and this is a very common AP exam question. Not only do you find something, but you explain what it means, or they tell you velocity is certain things. Now, if they might tell you specifically what the number is, they might, you know, there's a lot of different things. So, for example, let's say velocity is measured in meters per second, okay? And I give you, I guess it should be an example yet. And I give you v of 6 equals 5. Let's see how we can explain this. So what does v of 6 equal 5 tell us? How would I explain that? V of 6 equals 5. And I guess it should be an example. Explain the meaning in context. Explain, well, I guess that there's not really context. Indicate units. All right, so what does this mean? Most of you will get the half credit answer. And it's okay, and that's why I'm here to fix. Kind of giving you the answers already when I was trying to write this down. Take a stab. Without saying the word V, explain what this says. State what it is. That's all I'm asking. Take a chance here. We have nothing about speed. We have no lines here. State what it says without using the letter V.
Wait, I'm confused. So are we just saying the expression without V, or we're replacing V with something?
Yeah, replacing the word, replacing the V with that something, with what it is.
I'm so lost. Is this the part where we start doing VI, VF, or
No, you're just writing a word. You're just writing a word. You're writing a sentence. What does this mean?
V equals velocity.
Okay, so
So velocity.
Velocity, yeah. You gotta state velocity. If you don't state in your sentence velocity, then you're not explaining what it means. So you're not using any fancy notation. So the velocity, what?
Is it of 6?
Well, what does of 6 mean?
Miles per second?
No. What is the 6 referring to?
Is it the speed?
No, it is not. What is the 6 referring to? Remember.
Time? The time?
Yeah.
Okay.
At t equals 6, and if you want to say at time equals 6, at, I guess I'm going to erase this part. At t equals 6 seconds,
Velocity is at 5? No.
you know, velocity is not at, what is that?
Oh no, velocity equals 5.
Is what?
5 miles.
No.
Speed?
No, I haven't mentioned the word speed yet at all.
Meters per second.
Meters per second. That's it. So what I'm trying to get you to point out here is that you need to understand that this is the input, this is the time, and that number right there is the velocity, and of course these are my units. So the unit of time is seconds when it gives you velocity is meters per second, and so the input is time. And then the output is the velocity. So the whole thing is the velocity. So at time equals 6 seconds, at 6 seconds, all right, so sometimes we'll just say at 6 seconds, the velocity is 5. I get a lot of students that will say the velocity is 5 meters per second. Well, so for example, they'll just say the velocity is 5. Okay, but you will get no points on the AP exam because A, it says indicate units, so meters per second. And it'll say the velocity is 5 meters per second. Well, that's a false statement. The velocity is not 5 meters per second. At time equals 6, the velocity is 5 meters per second. At that specific point in time, the velocity is 5. Okay, taking away talking about units. The velocity is 5 at time equals 6. There's a big difference because velocity can be changing. So velocity can be 2, the velocity can be 3 at every point in time. Now, if it is a constant velocity, then the velocity might always be. If v of t was 5, and no matter what number you plug in for t, at any point in time, you always get 5, then it would be true that the velocity is 5. But this statement just saying that at time equals 6, the velocity is 5. Describing motion. So when we say velocity is 5 meters per second, what does that mean? So if the velocity is greater than 0, what is that? That means that our particle, I'm going to say it, is moving how? How is our particle moving? What would you say if you have a positive velocity? The particle is moving what? Up. That would be correct. Yeah, the particle is moving. We like to say the word forward. But of course, you could, if the context of the problem applies, you could say to the right. You could say up. The particle is moving up. If the context of the problem says that it's moving up and down, then a positive velocity means it's moving up. Typically, the word forward, our forward directions for up and down is up, and our forward direction for left and right is to the right. And so, therefore, if v of t is less than 0, so this is positive, negative, okay? So if my velocity is negative, what does that mean about my particle? What does that mean about the motion? How is it moving? How would it be moving?
Backwards?
Yeah, exactly. Moving backwards. And if I was given context further, I might say moving left. I might say moving down. But typically when we answer our problems, we'll just say backwards. So what do you think it means for the velocity to be 0?
It's not moving at all.
It's not moving. And anybody know another way of saying not moving?
Constant.
No. Well, position is constant, but we're describing the motion. So not moving is a valid description of how it's moving. But the word that we use in calculus, we say at rest. Stopped. And we might even say for an instant. So it's at rest. All right? And that's basically, so that is when the particle is at rest. Now, there's a very big uh-oh that happens all the time here. V of t, so V of t equals 0 means at rest. V of 0 means initial velocity. All right? So V of 0, when the input is 0, that means the velocity is 0. When we're talking about describing the motion, we're always going to describe the velocity. So there is a big difference. So when I say V of 6 equals 0, V of 6 equals 0 means the particle is at rest at t equals 6. Where if I said V of 0 equals 6, means the initial velocity, or I could have said at t equals 0, initial velocity is 6. So we gotta understand the difference between input, output, output, input. The input is 6. That means at time equals 6. If that equals 0, if velocity output is 0, the particle's at rest. If we plug 0 in, that means at time equals 0, the velocity is 6. So let's do an example here. S of t equals t to the 4th minus 2t. At t equals 3 is the particle moving forward, backward, or at rest. Justify. All right, you might say, I'll go with the other one, the more common one. Explain your reasoning. Okay, so this particle is asking me about motion. Okay, does the position function by itself tell me motion?
Do you want us to plug in 3 for t's?
if I did that, what does that find? Does that find motion?
It finds numbers. I don't know.
But what is that finding you? So if you plug in 3, and we have the knowledge now based on what we've covered, if you were to plug in 3, S of 3 finds you the position, how location at time equals 3. Is that going to help me with this question? Does that help me with forward, backward, or at rest?
Yes?
No.
No, it's not. Okay.
Does not. And it's good. It's good to know, because it's good to know that you might think that and switch it. Does not help for this question. Now, there are some questions that will specifically ask, what is the position? Where is the particle when? What is the position of the particle when? That would be, and that's typically your basic physics question. You plug into the position and you're done. But this is calculus. In calculus, you're going to always utilize the velocity in some capacity. All right? Basically, that's what you got to think. You're going to need to use the velocity. Now, your final answer might be by plugging in, but if you're plugging into the position, that might be like your final step. There's a very common question. We'll get to that example in here. So, when talking about forward, backwards, I need to know, and this means that when you hear moving forward, backwards, or at rest, you need to think velocity. All right. So velocity, velocity, velocity. Velocity is at the heart of all of our motion and our movement. Now, there's also something called acceleration, which I know you know of as well. We will get to that one, I think Monday actually. I'm going to break this up pretty much a lot more than I would ever do in the past. But in its the beginning part, we have to understand velocity for movement, how something's moving forward, moving backwards. Remember, velocity tells you forward, backwards, or at rest. It says, hey, I got to find out. So what do I need to find? What's the first thing I got to find then?
Velocity?
Perfect. I have to find the velocity. What is velocity? How do I find velocity? I think I know what you're saying, Ariana, but yeah, it's not. It is already in that form, I guess you can say. How do I find velocity? What am I given? What was I given in this problem?
Time?
I'm given more than just time. What am I given?
The position.
I'm given the position function. Given the position function, and I want to find the velocity function. How do I do that? Look up at your notes.
Function over time.
Okay, what is that? It's not the. You need to be way more specific. Yeah, I need to know the context that you know what you're referring to. What is that?
So S of t over 3.
No.
No.
No, that doesn't do anything. That doesn't find anything. You can't just divide by a number. That would be just changing the whole problem. That's why I want to make sure that you understand the notations. You are correct, Ariana, but I need to hear you say it or somebody say it.
ds over dt.
ds over dt. Okay, so I want to find that. That's what Jatasia had said though, and that's what she was looking to attempt to say. But what does that mean?
Wait, it's what we have in the notes, right?
What is that?
It's what we have in the notes. So is it like s prime of t?
Perfect. S prime of t. You need to take the derivative of position. Derivative. Derivative is an application. We're not just, and that's why I always say ds dt. It's not ds over dt, and I keep trying to really hammer this in. It's not a fraction. ds dt is not a fraction. It does not mean derivatives. It does not mean divide. You're taking the derivative of s with respect to time, to t. So that's what I was really trying to hammer home and making sure that you understand that it's the derivative. S prime of t is often better in terms of noting. But and what we're saying is that this is v of t. So you might see me state directly v of t equals, but I think the more applicable notation is just to say s prime of t, and you have to understand that s prime of t is velocity. When you see s and s represents position, the derivative of position is velocity. And we know how to do this. What is the derivative of position? Everybody should be able to get this in a heartbeat. It's about as easy as it gets in this course. What is the derivative?
V of t.
So what is the derivative function? What does it take it to derivative? It's as easy of a derivative as you could probably get in this course.
Four t power to the power 3 minus 2.
Minus 2. So there's my velocity. 4t cubed minus 2. It's as easy as a derivative as you take. It's just a power rule. There's no algebra manipulation needed. You're taking the derivative. You take the derivative of that position, and now you have velocity. In some problems, so what I'm stating here is that the velocity is 4t cubed minus 2. In some problems, I'll give you that directly, and I'll just say v of t is this. So some problems you're just given the velocity. All right. Where is it asking me to find the velocity at?
T equals 3.
So I want to find s prime of
3.
3. Which means that I'm going to do what with 3?
Plug in 3 into s prime of t.
Perfect.
Your s prime t equation.
Into my velocity. Correct. So I get 4, 3 cubed minus 2. Now, does it ask me what the velocity is? I just want to note this. Does this ask me for the specific value?
No, just asking for the direction.
Correct. So I just need to know if it's positive or negative. Is this positive or negative?
Positive. Positive.
Positive. It's greater than 0. I don't care really what the value is in this case, because that's what is that? That is 27 times 4, which is 108, yeah? Minus 2, so 106. Technically, it's 106. I'm trying to do some mental math. I don't even care if it's 106 or if it's 105, really, because I'm not asking that question. The question is just asking me, moving forward back at time equals 3. So this right here, that right there is the explanation. Greater than 0. So the particle is moving how? Forward, backwards, or at rest? Forward. At time equals 3 because velocity is greater than 0. S of t, let's go x. X of t equals 2t squared minus 8t plus 5. And I'm going to say t is greater than or equal to 0. That just, we're not going to have to pay too much attention to that right now. I'll be more in terms of tomorrow's part. Part A. Find when the particle is at rest. Find when the particle is at rest. Okay. When, generally, without a specific function, when is a particle at rest?
When it equals 0?
It's something that you're going to learn, you're going to have to learn, is that explanation would give you 0 points on the AP exam. This is where it becomes very, very, even more so important when we talk about particle motion. This is where the word "it" will get you in a lot of trouble.
The slope is equal to 0?
No.
When the motion equals 0?
No.
So when the particle is at rest?
When is the particle at rest? When what?
The particle is at rest when the motion equals 0.
What is the motion? It's what describes motion?
Velocity.
Here it goes. When v equals 0. Okay, so when velocity. So right now, basically the only things that you have to talk about is position or velocity. But I need to know which one you're referring to. So when you say it, and this is maybe you knew that you were gonna there was the velocity equals 0, but when you say it, you could have meant when position is 0. And I get people that set this equation right here equal to 0, and I'm like, you didn't even do any calculus. Calculus will either have you take a derivative or will use velocity because that is a derivative. Velocity is a derivative. So always remember that it's calculus. You're going to use a derivative. Sometimes you're given that derivative. So when velocity is 0. Okay? So what do I got to do? So if a particle is this when velocity is 0, then that means I need to first find velocity. Or I said velocity equal to 0. I could have just as easily said x prime of t. Okay? So the velocity is equal to, well, we just said it's x prime of t. What is it? Even easier than the previous one, I would say. What is the velocity function?
4t minus 8.
4t minus 8. Good. Second, we need to find when v of t was equal to 0. So I need to solve v of t.
4t minus 8 equals 0.
For t equals 8, so t equals
2.
And that's it. Now I could have, okay, so how does it work here? Yeah. Find the position when the particle is at rest. Find the position when the particle is at rest. Now, sometimes this question is the only question, and you don't get the previous one. So this one's a really easy problem for us to do because I already asked you the previous question. So what do I have to find? What do I have to do?
So to find the position, you would plug in 2 into the regular equation.
Well, what is the regular equation?
Xt equals 2t to the second power minus 8t.
To position. Plug 2 into position. Plug 2 into x of t. So I need to find x of 2. Now, if this is a very common question right here, but the question only states this. It doesn't give me the other problem. So what I have to do is, I got to figure out when the particle is at rest, and then I take my answer and I plug it in. So it's like a two-step problem. I first find when the time t. I need to find t first. So I need to find what t is. So I have to find velocity, set velocity equal to 0, and solve. And then take my answer and plug it back in. It's like a circle of life problem. So x of 2 gives me 2 times 2 squared minus 8 times 2 plus 5. That is 8 minus 16, which is negative 8, which equals negative 3. C. Find the initial velocity. Find the initial velocity. What do I got to do?
Is it when t equals 0?
No, when v equals 0 is at rest.
No, t equals 0.
T equals 0. You got to tell me more.
So you plug in 0 for where the t's are at the at 2t squared minus 8t plus 5.
And that's why I knew no. You were like saying it, and that's why I couldn't confirm. And it turned out that the it you were referring to was the wrong it. What do I got to find?
You have to find velocity.
Velocity. There you go. I got to plug 0 into the velocity. And that's why when you were saying plug in 0, it's like plugging 0 to what? It's like saying it, and then you chose the wrong it. So remember, v of t was 4t minus 8. So v of 0 is 4 times 0 minus 8, which is negative 8. D. Last question for the day. Find the initial speed. Hey, there's that word you've been looking for. What is? And so here's a quick little lesson. Speed is just equal to what? What is all? Well, I'll just tell you. Speed is just the absolute value or the magnitude of velocity. So in this case, the speed at 0 is equal to the absolute value of the velocity at 0, which is the absolute value of negative 8, which is positive 8. Speed is always positive. Speed is directionless. I'm gonna update the Delta math. You should only have one set of questions, 3 questions. That'll be your whole thing. We're just getting our understanding. You can see why I wanted to break this and at least get our starting introduction concepts into here. We're gonna expand on terms of this one tomorrow. We're gonna stay talking in terms of just up to velocity. I'm not gonna even introduce acceleration yet. That'll come on Wednesday. Um, it is class is over though. You have the Delta math. Get to thinking. Get to anything you learned is game in calculus. That's kind of like the theory of this. So have a good day. Come to office hours if you can. I'll see you tomorrow.